clays. It turns out it's some serious stuff. Clay's pretty complicated. It's part chemistry, part physics, and part geology. I simplified all the complicated jargon, so I hope this video was helpful and you learned something new. If you're watching this video, there's a high probability you've heard all the wonderful benefits of using clay to wash your hair. But there's still some mystery around clays. If clays don't produce suds or have surfactants, how do they work? The goal in all my videos is to empower you by showing you how things work. So in this video, we're going to go over what clays are and details on how they clean your hair and scalp. There's an ongoing debate on the grouping method of clays, but depending on what book you're reading, there's basically 4 major groups of clays: smectite group, kaolinite group, illite group, and chlorite group, and within these groups are subcategories. Clay is found all over the world in soil and in rocks. Clay particles are very, very tiny and flexible, so a large number of them can be compacted into a small block. But they also have the ability to swell so much that when water is added, that same amount can have a surface area so large it can be spread across hundreds of square meters. Let's quickly go over 2 simple definitions first. Absorption is when something soaks into or through another thing, and adsorption is when something sticks to another thing. So this water absorbed into this napkin, and the ball adsorbed onto this paddle. Okay, now that's out the way, let's take a closer look at what happens when you mix water with clay. It varies with different clays, but overall, when magnified, a clay particle has a flat, flaky shape. The large surface area on both sides has a lot of strong negative charged ions, while the thin edges has a few positive charged ions. A ridiculous amount of positive charged minerals and nutrients adsorb or stick on and even stack themselves on top of the negatively charged sides of each clay particle. And a few negative charged minerals and nutrients adsorb on top of the positively charged edges. Because according to electromagnetics, opposite charges attract while like charges repel. Just like with magnets, the positive charged side of one magnet has a strong attraction to the negative charged side of another magnet. But if both sides are positive, or if both sides are negative, they will repel each other. That's the same thing that happens on an atomic level with clay particles. The negative charged surfaces of the clay particles attract positive charged minerals, and the positive charged surfaces of the clay particles attract negative charged minerals. They stick to each other like magnets. That's why they're called clay minerals. Water molecules are dipolar, meaning they have both a positive charged side and a negative charged side. When you mix water and clay, a couple of things happen. The extra moisture causes the once tightly compact clay particle to swell and increase its surface area. And the water molecules detach the loosely held positive and negative charged minerals and a lot of the charged ions from the surface of the clay particles. Since water molecules are dipolar, the positive side adsorbs or sticks onto the negative charged things, and the negative side adsorbs or sticks onto the positive charged things. These are called hydration spheres, some with negative charged parameters and some with a positive charged parameter. So the water basically leaches out the power of the clay. And you end up with an activated, magnetic, and mineral-rich paste that's available to interact with whatever environment you put it in. Now that you know what's going on in here, let me show you what happens when you put this in your hair. Clay cleans your hair in 3 ways. It acts as an antibacterial, it detoxifies, and lifts oil from your scalp and hair. There's all types of craziness in your scalp and in your hair follicles, some good and some bad. Some clays have higher ionic activities than others, but for the most part, a clay-water mix has a ton of negative ionic energy. The electric field of these ions causes an electrostatic disruption of the wall of a bad bacteria cell, causing it to lose its hydration and die. To detox your hair is the act of removing actual toxins from your hair. Clays are also really good at this. They remove toxins and heavy metals like lead, mercury, arsenic, fluoride, and even chlorine from your hair in 2 main ways. 1, depending on what electrical charge the toxin has, a hydration sphere with an opposite charge can stick to it like a magnet and drag it out when you wash out the clay. Another way clay gets rid of toxins is with something called an ion exchange. An ion exchange is when good clay minerals swap with toxins with equal and like charge. So positive charged clay minerals swaps with positive charged toxins in a cation exchange, and negative charged clay minerals swaps with negative charged toxins in an anion exchange. The good healthy mineral stays in your hair, and the toxin is removed when you wash out the clay. This is referred to as remineralizing. Of course, this is a really simplified explanation. Activated clay is also a really powerful sponge. When you add water to it, it expands. Water quickly evaporates and it contracts. Under a microscope, the size difference from when it expands to when it contracts is really dramatic. How well a clay soaks up water and expands or swells is a measure of its absorption rate, and the more it expands when it's wet, the more it contracts when it dries. The removal of oily buildup happens when the clay dries and contracts on your hair. These pore spaces literally soak up and trap in oily buildup on your hair. Some clays do this more dramatically than others. So, as you can see, there's more to cleaning your hair than just removing product buildup. With the right recipe and measurements, clays can do all this without leaving your hair stripped or drying it out. But all its benefits don't stop there.